Performance Evaluation of Computer Systems Introduction. Outline. Introduction to Performance Evaluation. Objectives of Performance Evaluation. Techniques of Performance Evaluation. Metrics in Performance Evaluation. Introduction. Computer system users, administrators, and designers are all interested in performance evaluation. The goal in system performance evaluation is to provide the highest performance at the lowest cost. Computer performance evaluation has an important role in selection of computer systems, design of systems and applications, and analysis of existing systems. Objectives of performance study. Evaluating design alternatives, system design. Comparing two or more systems, system selection. Determining the optimal value of a parameter, system tuning. Finding the performance bottleneck identification. Characterizing the load on the system, workload characterization. Determining the number and sizes of components, capacity planning. Predicting the performance at future loads, forecasting. Basic terms. System, any collection of hardware, software and network. Metrics, criteria used to analysis the performance of the system or components. Workloads, the requests made by the users of the system. Performance evaluation activities. Performance evaluation of a system can be done at different stages of system development. System in planning and design stage. Use high-level models to obtain performance estimates for alternative system configurations and alternative designs. System is operational. Measure the system behavior with a view to improve the performance. Develop validated model that can be used for performance prediction and capacity planning. Techniques for performance evaluation. Performance measurement. Obtain measurement data by observing the events and activities on an existing system. Performance modeling. Represent the system by a model and manipulate the model to obtain information about system performance. Performance measurement. Measure the performance directly on a system. Need to characterize the workload placed on the system during measurement. Generally provide the most valid results. Nevertheless, not very flexible. May be difficult, or even impossible, to vary some workload parameters. Performance modeling. Model reasons of using models. An abstraction of the system obtained by making a set of assumptions about how the system works. Capture the essential characteristics of the system. Reasons of using models. Experimenting with the real system may be too costly, too risky, or too disruptive to system operation. System may only be in the design stage. Performance modeling. Workload characterization. Performance metrics. Captured the resource demands and intensity of the load brought to the system. Performance metrics. The measure of interest, such as mean response time, the number of transactions completed per second, the ratio of blocked connection requests, etc. Solution methods. Analytic modeling. Simulation modeling. Analytic modeling. Mathematical methods are used to obtain solutions to the performance measures of interest. Numerical results are easy to compute if a simple analytic solution is available. Useful approach when one only needs rough estimates of performance measures. Solutions to complex models may be difficult to obtain. TTF plus MTTR. Response time interval between user's request and system response time. Systems response time, Cont, can have two measures of response time. User starts, request. User finishes, request. System starts, execution. System starts, response. System finishes, response. Time, reaction. Time, response. Time 1, response. Time 2, can have two measures of response time. Both okay, but two preferred if execution long. Response time, Cont, turnaround time, time between submission of a job and completion of output. For batch job systems, reaction time, time between submission of a request and beginning of execution. Usually need to measure inside systems since nothing externally visible. Stretch factor, ratio of response time at load to response time at minimal load. Most systems have higher response time as load increases. Throughput, rate at which requests can be serviced by system, requests per unit time. Efficiency, ratio of maximum achievable throughput, x, 9.8 megabits per second, to nominal capacity, x, 10 megabits per second, 98%. For multiprocessor systems, ratio of n processor to that of one processor, in MIPS or flops, Efficiency. Number of processors. Utilization. Typically, fraction of time resource is busy serving requests. Time not being used is idle time. System managers often want to balance resources to have same utilization. X equal load on CPUs. But may not be possible. X CPU when I/O is bottleneck. May not be time. Processors busy. Total memory fraction used. Total. Miscellaneous metrics. Reliability. Probability of errors or mean time between errors. Error-free seconds. Availability. Fraction of time system is available to service requests. Fraction not available is downtime. Mean time to failure. MTTF is mean uptime. Useful. Since availability high, downtime small, may still be frequent and no good for long request. Definition of reliability. Recommendations E.800 of the International Telecommunications Union, E2T, defines reliability as follows. The ability of an item to perform a required function under given conditions for a given time interval. In this definition, an item may be a circuit board, a component on a circuit board, a module consisting of several circuit boards, a base transceiver station with several modules, a fiber optic transport system, or a mobile switching center, MSC, and all its subtending network elements. The definition includes systems with software. Basic definitions of reliability. Reliability RT. X. Time to failure of a system. FT. Distribution function of system lifetime. Mean time to system failure. FT. Density function of system lifetime. Definition of availability. Availability is closely related to reliability, and is also defined in E2T recommendation E.800 as follows. The ability of an item to be in a state to perform a required function at a given instant of time or at any instant of time within a given time interval, assuming that the external resources, if required, are provided. An important difference between reliability and availability is that reliability refers to failure-free operation during an interval, while availability refers to failure-free operation at a given instant of time, usually the time when a device or system is first accessed to provide a required function or service. Availability, Cont, instantaneous, point, availability at T. A T equals P, system working at T. Let HT be the convolution of F and G. GT, density function of system repair time. Then, inst. Availability, reliability. Availability, Cont, never failed in, 0, T, prob, RT. System working at time T. First failed and got repaired at time X less than T and up at end of interval, X, T, prob, X plus TX, T, X. First repair completed here. Availability, Cont, MTTR, mean time to repair, Y, repair period of the system. Availability and reliability are related but different. Availability, Cont. We can show from equation 1 that, also, high reliability / availability / safety, traditional applications, long life / life critical / safety critical, space missions, aircraft control, defense, nuclear systems, new applications, non-life critical/non-safety critical, business critical, banking, airline reservation, e-commerce applications, web hosting, telecommunication, scientific applications, non-critical. Motivation, high availability. IFIP-WG 10.4 faults are the cause of errors that may lead to failures. Failure occurs when a delivered service no longer complies with the specification. Error is that part of the system state which is liable to lead to subsequent failure. Fault is a judged or hypothesized cause of an error. Faults are the cause of errors that may lead to failures. Fault